Welcome to Curie Electronics. Today we are going to solve URSC 2019 Technical Assistant ISRO question paper for Electronics and Communication. This is a part 1. This will be completed in 2 parts. So total 60 questions are there. In first part, let's solve up to 30 questions. First question. Light is confined within the core of an optical fiber due to. So this is based on the fiber optics. The fiber optic cable, we have a core. On top of the core, or that is core is protected by one more sheath, that is the cladding. So this is the core, and what is there in this is cladding. Now there is something called refractive index of core. Refractive index of core. Let us take it as mu1. And for the cladding, the refractive index is mu2. Now, to propagate the light through this fiber optic cable, the refractive index of core, that is mu1, should be greater than mu2. Once this condition is satisfied, then there occurs total internal reflection at the boundary between this cladding and the core. So the answer is option D, total internal reflection at the core and cladding. They can give internal reflection also, so you have to take care of the word total internal reflection. This you don't forget, that is the refractive index of the core has to be higher than the refractive index of the cladding. That is how do you remember always like this. This let it be water. And here we have a this is a water, and this is the air. This is water. Let me write it. We should not take more time. Even then, I want to explain. I want to give you a little bit explanation so that it will be useful to you. So this is air. Okay, the red line below is water, above air. So when light enters, the light is entering like this. It can go for internal reflection if critical angle. The critical angle is greater than, I think, 90 degree. Okay, so from this you have to relate the optical fiber. The water is a denser. So refractive index. Refractive index of water is more than refractive index of air. Similarly, core is having higher refractive index compared to the cladding. Let's move to the second question. One of the main application of capacitance is to, this all of you knows, block DC and pass AC. Third question. Find the resistance between terminals A and B in the electric circuit of below figure. So here we have to use star to delta to star conversion. Okay, so this is the question. So see this part, this 3 resistor, this delta network I am going to replace with star network. I took top 3 resistors. This is 10 ohm, 40 ohm and 50 ohm. Now I should replace with a, this is what, this is A, this is CD. Now I have to replace this resistor with a star network. So this I will mention it as RA, RB, RC. Now what is RA? To find the RA, what you do, where it is, the RA is connected in between 10 ohm resistor and 40 ohm resistor. So it is 10 multiplied by 40 upon sum of all 3 resistors, that is 100. 400 upon 100 you got, right? So we'll get 4 ohms. You got 4 ohm. What about RB? RB equals, similarly, RB is connected in between 40 ohm and 50 ohm. So again I'll write 40 multiplied by 50 upon what is there? So what is sum of the all resistors, that is 100. So it is 500, no not 500, 5 4s are 20. 2000 upon 100. What do you get? We'll get 20 ohms. So what do you get? RC. Let's find the value of RC. RC equals, what is the value of RC? RC is connected in between 10 ohm and 50 ohm. So 10 multiplied by 50, the numerator, sum of the all resistors of the delta network, that is 100. 500 upon 100, you get 5 ohms, right? Now we have to replace this network. So how do you draw it? From A you are starting. Now I have a star network. Right, this is C and D. What are the values I got? RA equal to 4. RB equal to what I got? RB equal to 20 and RC equal to 5. Now 2 more resistors are connected here. Okay, these are the ends. Okay, I'll take it like this. What are the values? 25 ohm and 10 ohm. Now all of you know how to simplify. This 20 and 10 are in series. Similarly, 5 and 25 are in series. So this network will get reduced to 4 ohm in parallel with 2 resistors. Right. Both are 30 ohms. This is our A and B. Now if we simplify, what we get? When 2 resistors of same value are in parallel, what we use, which equation we use? RT equal to RT equals R upon N. So here we have 30. 30, how many resistors of 30 ohms? 2. So we'll get, so finally we'll end up with 2 series resistors. What is the value? Value equals 4 ohm plus 15 ohm. So what is the effective resistance? That is 19 ohms. So answer is option B, 19 ohms. Next question. In an current in an intrinsic semiconductor is equal to, intrinsic semiconductor means pure semiconductor. So total current is current due to holes plus current due to electrons. So the answer is option C. Electron current plus Hall current in a pure semiconductor. Next question. When we tune in any desired station in a radio receiver by rotating the tuning control, we vary. Actually, when we tune a radio receiver, we are changing the capacitance. That capacitor is known as gang capacitor. Gang capacitor. So to tune a channel in a radio receiver, we vary the capacitance. The glider goes from a position of 30.4 cm at a time t equal to 1/3 second to a position of 113 cm at a time t equal to 5/3 seconds. The average velocity of the glider during this interval is. So we have to find the average velocity. So average velocity equals change in distance. Change in distance upon what is velocity? Distance by time. Time interval. Time interval. So what is the change in distance? Initially it was at 30.4 cm, then it has moved to 113 cm. So 113 minus 30.4 upon 5/3 minus 1/3. So if we simplify this, right, we have to simplify it. It comes to 113 minus 30.4. It comes to 82.6 upon 4/3. And if you simplify this, what do you get? You will get 61.95 centimeter. Answer is option B. Question number 7. Force causes. See, now when a body is at rest, when you push the body, what happens? It starts moving. That means it has got acceleration. So when a body is moving, if you use a force and stop it, the acceleration is decreasing. So force causes acceleration on a body. Option B is the right answer. Which of the following colors of light has the greatest energy per photon? This photon energy it is given as E equal to HF or H mu. So if you look at this, if frequency increases, what happens? If frequency increases, energy also increases. Now, in the visible light, we know VIBGYOR. So visible light has a wavelength of, what is the wavelength of visible light? It is from 400 nanometer to 780 nanometer. 780 nanometer. So which has the highest frequency? 780 nanometer. Right. Now which which has the longest highest wavelength? That is red. And the lowest wavelength is violet. So violet is having the highest frequency. So photon energy is proportional to frequency. So out of given blue, yellow, red and violet, violet is having the highest frequency. So this violet has got the greatest photon energy. So this is better to remember this equation. Photon energy equal to hf or h mu. H is the Planck's constant. The ratio of the magnitude of the applied force to the cross-sectional area of the wire is called. We have a direct equation, that is stress equal to force upon cross-sectional area. The question, what is the ratio? Cross-sectional area of the wire to applied force. So the answer is stress of the wire, option B, stress of the wire. Which of the following is not a fundamental quantity? All of you know which are the fundamental quantities. Mass, length and time are the fundamental quantities. So this perimeter is the derived quantity. Next question. A 20 kg block is placed on a smooth horizontal table. A horizontal force 12 Newton is applied to the block. The position of the block at 5 seconds is. So we have a stationary block. On that we have a stationary block on a smooth surface, and it has got a mass, and we are applying a force, and the position is changing. The position of the block we have to find. That means distance we have to find. To find the distance, we can use the equation S equal to ut plus half at square. We have the initial velocity, we know what u is, what initial velocity. Initial velocity we know, that is 0. The block was at rest. The block was placed, so it was at rest. So u equals 0. T he has given equal to 5 seconds. But acceleration we don't know. Acceleration we have to find. Now, according to Newton's second law, force is equal to mass into acceleration. Force he has given. What he has given? 12 Newton. What is the mass? 20 kg. What is the acceleration? Acceleration we have to find. So A equals 12 upon 20. What is the answer? 12 divided by 10, that is equal to 1.2. Half of 1.2 equal to 0.6 meter per second square. It is 0.6. So acceleration we got. Now put the values in the equation. U equal to 0. So 0 into 5 seconds will be 0 only. Plus half. What's the acceleration we found? That is 0.6 meter per second square multiplied by t square. 5 seconds, it is 25. 5 square equal to 25. If you simplify, what you get? 0.6 multiplied by 25. 0.6 multiplied by 25. 15 upon 2 we will get. 15 upon 2, that is 7.5 meters we will get. So the answer is option B is the answer, 7.5 meter. Let's move to the 12th question. What is the 12th question? It is based on which of the following statement is correct. So let's see what is a 4x1 multiplexer. A multiplexer means many to 1. That means many input will be there. Many to 1. Many to 1, that is the multiplexer or mux. So a 4 is to 4 cross 1 multiplexer mux, we should have 4 input lines, right? 4 inputs lines. Input 1 to 2, 3, 4 input. It should have 4 inputs. 1 output, because multiplexer is a many to 1 circuit. 1 output it should have. And to select out of these 4 inputs, we should have 2 select lines, S1, S0, S1, S0. Which is the answer? The answer is, what is the first option? A 4 cross 1 multiplexer has 4 input lines, 2 selection lines and 1 output line. The first option A is the answer, right? A 4 cross 1 multiplexer has 4 input lines, right? 2 selection lines, right? And 1 output line. Which of the following statement is correct? It is based on the bandwidth. Now let's quickly compare what is we have. We have PC. Let me write it a little right. PCM and what we have? DPCM. And let me write it here as a parameter. At least 1 or 2 parameters we will compare. Otherwise, solving this question paper is not at all useful, because very rarely this questions repeats. We have to learn the concepts surrounding the questions. So in the PCM, if you parameter number of, let me parameter number of bits in sample. That is represented as M, number of bits in a single sample, in a sample. So in PCM, it is 8 bits are there, okay, in a sample. In differential PCM, it could be 4 or 6. So bandwidth is given by MW. M is the bits in a sample, bits in sample, number of bits per sample. Let me write it properly. Number of bits per sample. Number of bits per sample. So in PCM we have 8 bits per sample. In DPCM it is going to be 4 or 6. Then what about bandwidth? Second one is the bandwidth. Bandwidth is proportional to is equal to MW. In PCM, M is higher, that is 8. So it is higher. Bandwidth is high, low. And there is one more thing is there, something called sampling rate. Sampling rate. Sampling rate of both are 8 kilohertz. 8 kilohertz. And finally, bit rate. There is one more term, bit rate, represented by RB. Bit rate, RB. This is equal to RB equals M Fs. Okay, so this is going to be 64 kilohertz for PCM. For DPCM, it is going to be lesser than that. Please find out yourself. So what is the answer for this question? Which of the following statement is correct? PCM bandwidth requirement of DPCM is less than PCM. The answer is option C. Electric field. The electric field due to a point charge at a distance r is, the electric field is given as 1 upon 4 pi epsilon naught q upon r square for a point charge. So the electric field is inversely proportional to r square from this equation. Question number 15. A car initially traveling at 30 km per hour. So U has given us 30 km per hour. So we have to convert this to meter per second. How do you convert? 1 kilometer equal to 1000 meters. So multiply by 1000. However, how do you convert to seconds? That is 60 multiplied by 60. If you simplify this, what do you get? Let me write it here. 60. If you simplify this, you'll get 8.3 meter per second. You will get it. And now what do you use? Same. You use the whatever equation we have solved previously. Also we have used SC equal to UT plus half AT square. So this equation, try to remember. SC equal to, try to remember. Now you should remember this equation and all very fundamental physics you should know. SC is equal to UT plus half AT square. Now let's try to put the values. U equal to 8.3. What is the time? 15 seconds. Plus half. What is the acceleration he has given? 1.5 meter per second square. Multiplied by t square. 15 square equal to what? 225. If you simplify this, what do you get? You should get 293.75. I am not solving it completely to save some time. Okay, this you can solve. It's arithmetic meter. So the answer is option D is the right answer. Option D is the right answer. Question number 16. A transformer has 350. It based on transformer turns ratio. Turns ratio is what? N1 upon N2 equals E1 upon E2 equals I2 upon I1. This is the turns ratio equation. Now in the question, what is the N1? We have to find the E2 we have to find. What is N1? Now has primary turns, that is N1. 350 primary turns. So 350 upon, what is the secondary turns? 1050 equals, what is the value of E1? What is our primary voltage? 230 volt upon E2. E2 we have to find. If we cross multiply, what we get? E2 equals 230 multiplied by 1050. Divided by 350. If you simplify this, what you get? You get 690 volt. 690 volt you got. But in a transformer, no, let me write one more sentence. Ideal transformer. Input power equals output power. Also, ideal as well as practical transformer, frequency remains same. Input frequency as well as the output frequency is same. Frequency remains same in a transformer. frequency remains same. So this also you should keep in mind. Frequency remains same. Now you tell me the answer. Which is the answer? It is 290 volt. We have connected a 230 volt 50 hertz input source. So it is answer is option A. 690 volt 50 hertz. Let's move to the next question. If we say if a transmission line is terminated with a resistance equal to its characteristics impedance. See, we have a transmission line. Okay. So this is our characteristics impedance, that is Z0. And we are connecting a load here. This is our load impedance CL. What happens if this load impedance and the transmission line characteristic impedance is perfectly matched? There won't be any reflection of the wave. So standing wave ratio will be minimum. So for this question, answer is option B. Okay. There is one term called voltage standing wave ratio, that is given upon 1 plus mod of reflection coefficient upon 1 minus mod of reflection coefficient. We are not bothered about the phase, that is why we take the mode. Now if it is perfectly matching, this reflection coefficient is going to be 0. So then we will get a value of 1 if reflection coefficient equal to 0. That means it's perfectly matched load. Express the power dissipated in a 100 ohm resistor in dB relative to 1 milliwatt when the voltage across the resistor is 1 volt Vrms. So power equal to RMS voltage square upon R. What is the, we have to find the power dissipated with respect to 1 milliwatt. So 1 milliwatt power, we will take it as input. So what is the voltage? We have 1 upon, what is the value of R? 100. This is what the output power. Output power. What is the input power? Input power he has given us 1 milliwatt. 1 milliwatt. Now in dB, if you want to express the power in dB, how do you write? Power in dB equals 10 log to the base 10. Okay, it is to the base 10. P out, power out upon power in, P in. So which equal to what? P out upon power in. So 10 log of 10 log of to the base 10. Log of to the base 10. What is the output power? That is 1 upon 100 upon input power is 1 milliwatt. So we can write it as 1 upon 1000. Here what we will get? We will get 10 log 10 of 10 we will get. What is log 10 to the base 10? That is equal to 1. So 10 multiplied by 1 is equal to 10 dB. So we will get answer as 10 dB. Yeah, it is there in the answer is option C is the right answer. So you should know this equation, power in dB. Next question. A tuned circuit is resonant at 40 MHz. its Q is 100 bandwidth. He has given the resonance frequency, that is FR equal to 4 megahertz and Q equals 100. What is there? We have to find the bandwidth is the question. Q, there's a equation to find Q. Q equals resonant frequency upon bandwidth. So now what we know, we want the bandwidth. If we cross multiply, what we get? It is FR upon Q, that is 4 megahertz, 4 into 10 to the power 6 upon, it is 100, right? We can write it as 4 into 10 to the power 4. That means we can write it as 40 into 10 to the power 3. This is equal to 40 kilohertz is the answer. So you should know this. What we should know? We should know this equation. Q factor, quality factor equal to resonance frequency upon bandwidth. Question number 20. What is the modulation index in a frequency modulator signal with a carrier frequency of 100 MHz, modulating frequency of 4 kHz and a frequency deviation of 50 kHz? So, we have to find the modulation index of FM. Which is equal to maximum deviation in the deviation in the carrier frequency, that is delta F upon maximum modulating signal frequency. What we get? Delta F, deviation here is given as 50 kilohertz upon, what is the maximum frequency deviation? 4 kilohertz. So if you divide 50 upon 4, what do we get? It is 10 fours are 40, 48. That means 12.5 we get. So 12.5 is the answer. Option C. So you should know the equation of modulation index. You could watch my video on modulation index of FM to understand it better. Sorry. In a transistor, if the current gain is 100 and collector current is 5 milliamps, the base current, so beta is 100. What is the collector current? IC is given as 5 milliamps. IB we have to find. IB is a question. IB we have to find. So IC equals beta times IB. So what is IB? IB equals IC upon beta, which equals, what is the value for IC? 5 milliamps upon 100. So it comes, this 100 when you take it up, we can write it as 10 to the power minus 2. So it comes 5 multiplied by 10 to the power minus 5 milliamps. We don't have 5. Now we have to write it in microamps. If you want to multiply by, what I will do? 5 10 to the power minus 5. This is the answer. We can divide and multiply by, I will multiply by 10 to the power minus 1. So I will divide by 10. This is same. Now That's not the right way. So we have 10 to the power minus 5. Multiply and divide by 10. Then what happens? 50 multiplied by, when the 10 comes up, so what it will become? Minus 6. So I can write it as 50 microamps. So 50 microamps is the base current. So the answer is option D. Option D is the right answer. When a transistor is used as a switch, when we use a transistor, how do you, let me write a diagram. Let me draw the diagram, right? This is our RC resistor. So now, if you apply input signal or low and high, this is, let be 5 volt. And the output, we will get a signal like this, which goes from 5 volt to 0 volt. When it is possible to get the output like this switching waveform, it has to be, the transistor has to work in saturation as well as cutoff. So the answer is option D. In NPN transistor, emitter junction is forward biased and collector junction is reverse biased. Then the transistor will operate in active region. Active region. Now there are, all of you know, there are two junctions, that is the base emitter junction and the base collector junction. If base emitter by junction, the question what is given? Base emitter junction is forward biased and the base collector junction is reverse biased. So the transistor is in active region. When both junctions are forward biased, the transistor is in saturation. When both junctions are reverse biased, transistor is in cutoff. When it is cut off, we will get the, what is the collector voltage. So 5 volt, the 5 volt we will get as per the previous question. Now whenever this is reverse biased, whenever this is this base collector junction is forward biased, there is one more called reverse active region. Reverse active. Let's move to the next question. The desirable SWR on a transmission line is, in a transmission line, desirable SWR value is 1. We have seen one of these previous questions, that's a voltage standing wave ratio. It is equal to 1 plus rho, that is the reflection coefficient, minus 1 minus mod of reflection coefficient. Now this reflection coefficient will vary from 0 to 1. Now if we give reflection coefficient, now let's take 1, let's take put 0. If you put 0, put reflection coefficient equal to 0, then you will get 1 upon 1 equal to 1. Now let's put 1. Put a 1 equal to reflection coefficient equal to 1. Then what happens? We will get here, if you solve, 1 plus 1 upon 1 minus 1, that will get 2 upon 0. That is infinity. That means infinite. Infinite. That means when our reflection coefficient varies from 0 to 1, our VSWR or SWR value varies from 1 to infinity. So desirable value is 1. We don't want any reflection. Whatever the transmitted signal, it should go to the load. So this is the equation. Question number 25. Which of the following is a measure of the antenna's radiated power in a given direction? That is, the answer is gain. We want, in an antenna is used to get at a particular direction, we should be able to transmit the power, RF power. So it is the gain, the given direction. A radio receiver is tuned to 750 kHz and its oscillator frequency is 925 kHz. The image frequency would be. So what is the, first we have to find the intermediate frequency, IF. IF equal to signal oscillator frequency, local oscillator frequency, F oscillator, that is the signal is the oscillator and the receiver, F oscillator minus F signal. What is the F oscillator? 925 kHz minus what is the signal frequency which we are tuned to? 750 kHz. So what is the intermediate frequency? 175 kHz. kHz. Now, what is the image frequency? Image frequency is given as image frequency equals to signal frequency, that is Fs plus or minus 2 times intermediate frequency, IF, intermediate frequency. So what is our signal frequency here? That is 750 kHz plus 2 times the IF, that is 175 kHz. So 350. So we will get 1100 kHz. Do we have it in the answer? Yeah, we have 1100 kHz. The answer is option B is the answer. So here we should know how to find the image frequency. Which of the following is the most stable oscillator? That all of us know the crystal controlled oscillator are the most stable oscillator. It is used in microcontroller based systems or microprocessor based systems where we need a stable clock, precise clock. Next question. Tesla is the unit of magnetic flux density. Magnetic flux density. There is another unit also is there, that is Weber per meter square. There is one more unit, that is the Gauss. Here 1 Tesla or 1 Tesla or 1 Tesla or what? 1 Weber per meter square equal to 10,000 Gauss. This is the unit of magnetic what? Magnetic flux density. Question number 29. Inductive reactance XL of a inductor is. What is XL? XL equal to 2 pi FL. If you look at this equation with respect to frequency, the inductive reactance increases. If frequency increases, inductive reactance increases. If frequency decreases, inductive reactance decreases. So which is the suitable option? Directly proportional to frequency. Answer is the option C, directly proportional to frequency. Today's last question. An integrated circuit is also known as, an integrated circuits look like this. And a capacitor. So here we will give the input, here we will take out the output. This is the integrated circuit. If you look at this circuit carefully, what is happening? It will allow DC. That means it is a low pass filter. Low pass filter. Similarly, we have a high pass filter. That is a capacitor and a resistor connected like this. It's RC, okay, RC. Here we are applying the input and here we are taking the output with respect to ground output. So this is a high pass circuit. High pass filter or differentiator. You fill the remaining spelling, differentiator. So the answer for this question, an integrator is also a low pass circuit. Option A is the right answer. So I hope these videos are useful to you. If you like the videos, please hit the like button. Also share with your friends. The remaining 30 questions we will solve in the next part.